Okay, so this is the explanation for did the motorist exceed the speed limit. So what I've done here is I've plotted the points of the motorist distance from the supermarket, with y being the distance and x being the time in seconds, and this distance y is in meters. So in order to find out what if the motorist exceeded the speed limit, we want to find out like the gradient of the graph, correct? So one way to do this would be through differentiation. So for differentiation, you need to find a function first. The thing about this set of values that I've plotted on the graph is that we don't have a function that can describe this set of values very accurately. So originally, by looking at this shape, you would think that, oh, maybe you should use a cubic curve. But the thing about using a cubic curve is that the accuracy for a cubic curve, if you were to fit the cubic curve into this set of values, is not very accurate. So something better you could do would to just focus on these 3 points over here at x equals 60, 70, and 80. The reason for this is because, as you can see, if we were to draw an imaginary line here, the slope or the gradient of this part is the steepest. So if we can find out if the motorist exceeded the speed limit at this point, then it means definitely the motorist exceeded the speed limit for the entire journey, because this area over here is the fastest. Okay, so by just focusing on these 3 points, I will actually get rid of this one first. So we will just focus on 3 points. So we use decimals and instead of using a cubic curve, we use a quadratic curve to describe. So y1 ax1 square plus bx1 plus c. So as you can see, we have a quadratic curve very nicely fit onto these 3 set of values. And now what I will add is I will set the domain to be 60, to be between 60 and 80. Wait, x1. Okay, so as you can see, this is the curve that describes these 3 set of values. So if we can find the gradient of this curve at any point, by true differentiation, we can find out what is the speed of the motorist. Okay, so what you do next is as you can see, our values for A, B, and C are 1.26, negative 1.5, and C is 4300. So I'll type the equation out. Y equals to 1.26 x squared plus minus 141.5 x plus 4300. Correct? And remember that this is the domain. So what we need to do in order to find the gradient is to differentiate the equation. So how I'll do that is bring down the 2 from here. So 1.26 times 2, 2.52 x. We remove 1 from the power. And minus 141.5 because we differentiate the x term and then the constant just gets removed. So one thing that's important is again to add this domain to our equation. Okay, so as you can see, this graph over here is the values of our gradient at x equals to 60 to 80. So what this means is that if I were to say let the speed be 15, this graph over here, this black color line, is the graph of the motorist's speed at x equals to 60, between x equals 60 and x equals 80. So between x equals 60 and x equals 80, his maximum speed was 60.1 meters per second, and his minimum speed was 9.7 meters per second. So we can see that the intersection between y equals 15 and this and this line over here, which shows his speed, is 62.103. So this number over here, this significance, is the number of seconds it took before the man passed the speed limit, which is 15 meters per second. So as you can see, the man definitely did pass the speed limit, because from x equals to 62 seconds all the way until 80 seconds, his speed increased from 15 all the way until 60. So this shows that he did in fact exceed the speed limit.